Welcome to next edu classes. Today we shall start probability theory. The probability theory, the starting probability theory is main thing is random experiment. Associated with random experiment. Experiment may be of two types. One is called deterministic experiment and other is called random experiment. So what is deterministic experiment? An experiment is called deterministic if given the condition under which it is carried out, the outcome is always predetermined. One example, any chemical reaction under certain given under certain condition is always deterministic. What is random experiment? Random experiment is that type of experiment whose all possible results are known, which can be repeated under identical condition, but it is not possible to predict the outcome of any particular trial in advance. Example, tossing of a coin, throwing of a die, drawing of a card from a full 52 pack of 52 playing cards. These are the etc. are example of random experiment. Now I start writing the definition. Deterministic experiment. Deterministic experiment. An experiment is called deterministic. Deterministic if given the condition under which it is carried out, the outcome is always predetermined. Example, any chemical reaction under certain condition is always deterministic. We know what will be the result. Deterministic. Then we start random experiment. Random experiment in short it is right RE. Random experiment is that type of experiment whose all possible results are known, which can be repeated under identical condition, but it is not possible to predict the outcome of any trial, of any particular trial in advance. Okay. Random experiment is that type of experiment whose all possible results are known, which can be repeated under identical condition, but it is not possible to predict the outcome of any particular trial in advance. Example, one coin is tossed. You know very well the result will be either head or tail. But can you say that you will get head or you will get tail in advance? It is not possible. That tossing of a coin is a random experiment. Throwing of a die. you know very well the result will be either 1 dot, 2 dot, 3 dot, 4 dot, 5 dot, 6 dot, but it is not possible for anybody to predict the outcome in advance. I will get Sakka, you can't say in advance. These are the random example of random experiment. Okay? Yeah. Right? Tossing of a coin. Second, throwing of a die. These are the example of random experiment. Then we come trial. What is trial? Any particular execution of the random experiment is called trial. Okay, right? Any particular execution of the random experiment is called a trial. Okay. After trial, you will get some result. That result is called outcome. The result which you have seen, that is called outcome. A result which you explain to somebody, that is called event. Then outcome. What is outcome? The result of the random experiment that observed in a particular trial is called an outcome. After that, you have to explain to somebody, that then it is called event. What is event? The result, but the outcome. The outcome defined in a suitable manner is called an event. Event may be of two types. One is called simple or elementary event. Elementary event. Simple or elementary means the event which can't be further decomposed into simpler event is called simple event. Or the event which can be decomposed to further simpler events is called compound event. Outcome is the result which you have observed or which you have seen. That is called outcome. Outcome is expressed in some either in words or in figures is called event. That means when one coin is tossed, what is the outcome? Outcome is either you will get the upper face of the coin or bottom face of the coin. This is the outcome. The upper face of the coin is named occurrence of head. That is event. That is required to express to somebody. When one baby is born, we say either one boy child or a girl child. But to explain somebody, then it requires the name of the baby. A, B, C, D, whatever be the name, we express today is the birthday of A, but today is the birthday of B. Okay. The event is when outcome is defined by somebody is called event. Event may be two types, elementary event. The event which can't be further decomposed. Can't be further decomposed into simpler events is called an elementary event. Elementary event, compound or composite event the event which can be, this is can't be, this is can be further decomposed into simpler events is called a compound event. Okay, then example, one coin is tossed 3 times. Random experiment, we consider one coin is tossed 3 times, or the same thing, or 3 coins are tossed once. This is same thing. What are the outcome? Outcome is H, 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 T, H, T, H, H, T, 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 H, H, T, H, T, 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 H, and T, T, T. Okay, these are the outcome. Then all these are elementary event that can be happen. 3H can be happen in one way. HHT, my first H, second H, and T, that also can be happen in one way. All these are elementary event. All these are elementary events. But when we group the elementary events in such a manner, suppose no head is the name of the event, one head, two heads, three heads. No head, under no head, the one is outcome, only one outcome, that is TTT. Three heads, one outcome, that is HHH. So the no head and one head are elementary event. But one head, HTT, THT, TTH, then HHT, HTH, THH, these are the compound event. Clear? Compound event. Okay. Then we example, either one coin is tossed 3 times, or this the same experiment we can done with 3 coins together. 3 coins are tossed once. Now, what will be the outcome? The outcome will be 2 cube, 2 into 2 into 2, that is 2 cube, that is equal to 8. The 8 possible outcome, these are the 8 possible outcome. HHH, HHT, HTH, HTT, THH, THT, TTH, and TTT. All these are elementary events. Then we compound this event in this manner. No head, one event, one head, 2 head, 3 head. The no head and 3 head can be happen one way only, that is either TTT or HHH. So these are elementary event. But one head can be executed in 3 ways, either HTT or THT or TTH. So it is a compound event. 2 events can be happen in 3 ways, HHT, HTH, THH. So it is also a compound event. I think concept is okay. Then we come, what is sample space? Sample space, usually it is denoted by capital S. The whole set of all elementary events is called sample space. The whole set of all elementary events, the whole set of elementary events in a random experiment is called a sample space. and each elementary event is called a sample point. That means S. S is a sample space. So set is denoted by curly bracket H T T T H T T T H H H H H H T H T H H T T T H H T H H T H T T T H and T T T. These are called elementary event or sample space. Total set is called sample space. These are called sample point. Clear? Now we discuss types of sample space. That is very, very important. Types of sample space. Sample space may be three types. One is called discrete sample space with countable finite number of sample points. Another is also called discrete sample space with countable infinite number of sample points. A third is called continuous sample space, that is uncountable infinite number of sample points. Let us come one by one. The first one is called a sample space. A sample space with countable and finite number of elementary events is called a discrete means countable, discrete sample space. Example, the previous example, random experiment, one coin is tossed 3 times. Here number of elementary events is countable and finite, and this finite number is 8. Here elementary events are countable and finite value is 8. Okay. Second one, a sample space with countable and infinite number of elementary events is also called a discrete sample. One example, the example is random experiment, one coin is tossed repeatedly. এখানে coin is tossed 3 times, that is a finite number. One coin is tossed repeatedly until first head appears. Then what will be the outcome? Outcome key, you may get head, then you may get head, first tail, then head. You may get first tail, second tail, then head. In this manner, that is sample space H, TH, ETH, TTTH, then so on. You will get infinite number of T, then H. That means possible outcome. These are all elementary events. These elementary events are countable. Here, elementary events are countable. Countable means key, which can be isolated from each other. Countable but infinite. We can't say what will be the finite value. That is infinite. Third one, sample space with uncountable infinite of sample points. A sample space with uncountable, then not possible to count, uncountable and infinite. That means number of outcomes is infinite, but these are isolated from each other. When these are not isolated from each other, it is not possible to count. That is not possible to isolate each other. Uncountable, infinite number of sample points, number of elementary events. Number of elementary events is called a continuous sample space. Elementary events is called a continuous. Continuous means not possible to count. That is, in other words, it is measurable. Continuous sample space. Can you say one example? Sample space when outcomes are not possible to isolate from each other. Suppose weight of a baby born in a hospital. The random experiment. Example, random experiment. Weight of a newly born baby in a hospital. Weight may be here. Weight may be key. This is the range. This is the, suppose this is the minimum weight of a baby. This is the maximum weight of a baby. Within this range, all possible values within this range may be the weight of a newly born baby. Is it possible to count? It is not possible to count. It is not possible to count. So this number of all these small dots are elementary events, but we can't say what is the exact weight it means. Hence, elementary events are not possible to isolate. That is not possible to count. That is uncountable and infinite. Here, elementary events are not possible to isolate each other. Events are not possible to isolate each other. That means are uncountable. Uncountable and infinite. Okay. In MN1 course, we are interested with sample space which consists countable and finite number sample points. Another two cases we shall discuss in MN2 syllabus. Okay. So our main target in MN1 syllabus, sample space with countable finite number of sample points. Three important terms associated with sample space having countable and finite number of sample points. Clear? Three important terms. One is exhaustive set of events. Exhaustive set of events. A set of events is said to be exhaustive if at least one of them must occur. A set of events is exhaustive if at least one of them must occur. I mean, this is the total possible outcomes. Elementary event and sample space are definitely exhaustive. Elementary event samples exhaustive means the totality of all possible outcomes. Totality of all possible outcomes. The sample space is the totality of all possible outcomes. So elementary events in the sample space has to definitely exhaustive. When we consider events may be elementary, may be compound. The exhaustive set of events means a set of events of which one must occur. A set of events is called exhaustive. Is called exhaustive if at least set of events is said to be exhaustive if at least one of them must. Elementary events in a sample space is definitely exhaustive. Second, mutually exclusive events. Mutually exclusive events. Mutually exclusive means no two can occur simultaneously. Occurrence of one prevents the occurrence of the other. That is called mutually exclusive, but it is also called incompatible. One can't be compatible with other. Examples, আমি লাস্টে আসছি. A set of events is called mutually exclusive. Mutually exclusive if no two can occur, no two of them can occur simultaneously. Here also elementary events in a sample space is definitely mutually exclusive. Clear? Third is equally likely. A set of events is said to be equally likely if no one can occur in preference of any other. Equally likely events, a set of events is said to be equally likely if no one can occur in reference to any other. Elementary events in a sample space is assumed to be equally likely. Now we discuss with an example. One example. We take same example, random experiment. One coin is tossed 3 times. One coin is tossed 3 times. So what are the possible outcome? The sample space HHH, HHT, HTH, HTT, THH, THT, TTH, and TTT. These are all elementary events. These elementary events, these are all elementary events, and elementary events are collectively exhaustive. দেখো at least one of them must occur. এই আটটা ইভেন্টের প্রত্যেক একটাকে হতেই হবে। ওকে, they are mutually exclusive. No two can occur simultaneously. Either you will get HHH or you say HHT, and all are assumed to be equally likely. We think the coins are perfect. তার মানে here all these are elementary events which are one, collectively exhaustive, mutually exclusive, and third, equally likely. But if you consider compound event, suppose no head, one head, two heads, three heads. These four here these events are not all elementary events. Some element, these two elementary events, but these two compound events. So here these events, that means elementary compound mixed. These events are collectively exhaustive. Second one, mutually exclusive, but are not equally likely because we have discussed already, head can be occurred in one way, three heads can be occurred in one way, but one head and two head can occur in three ways, but they are not equally likely. But if we consider, suppose at most one head, that is the name of the event, at most one head, and another is at least two heads. Then these two events, at most one head can be happen. These two means at most one head, these two means at least two head. These two events here, these two events together, these two events are one, collectively exhaustive, second, mutually exclusive, and third, they are equally likely also. They are equally likely. Then after that, in next video, we shall discuss about classical definition of probability. That means we are solving problems, how to solve the problems using of the probability using classical definition. That is, classical definition is the basic thing. Next video, we shall start with the classical definition of probability. Classical means that is conventional, procholito, and solving problems and solving few problems using classical definition, and after that we right, theorems on probability, theorems on probability theory based on classical definition of probability. Okay.